Imagine an invisible dark sphere weighing 10 million suns zooming through the void at almost 1,000 kilometers per second. It's plowing through deep space so violently, it's ripping a 200,000 light-year-long trail of star fire behind it, a contrail of newborn suns twice as long as our entire galaxy. This isn't some cosmic horror. It's a real object called RBH1, which literally means the first runaway supermassive black hole ever confirmed. It was caught in late 2025 by the James Webb Space Telescope. It saw a massive bow shock where this monster is crushing gas so hard it's glowing in infrared. This discovery shook astronomers to their core. Turns out, even supermassive black holes can zoom around the cosmos like monstrous missiles able to destroy whole star systems. Which begs the question, how many kinds of black holes are really lurking out there? Welcome to our ultimate bestiary of the void that challenges the concept of reality itself. Facing the reality of a universe filled with runaway monsters makes our own civilization feel incredibly fragile. If the lights went out today, would you know how to rebuild? That's why I want to show you this beauty. The book, The Ultimate Guide to Rebuilding a Civilization, a modern artifact in printed form. This 400-page tome weighs over 6 pounds and is designed to be the ultimate backup for humanity. What I personally love are these hand-drawn steampunk-style spreads. Look at the detail on this mechanical loom or the blueprints for a blast furnace. It's like looking at the source code of humanity. One of my favorite sections is the chemistry part. It explains how to make gunpowder and medicine from basic earth minerals. It's fascinating, even if you never have to use it. But here's the coolest part. The book itself is a mystery. Hidden within these pages is an actual quest. There are clues, riddles, and secret symbols woven into the illustrations. If you can solve them, they lead to a hidden secret on a dedicated website. It's a tribute to human imagination and the ultimate gift for anyone who loves science, history, or just beautiful objects. Click the link in the description or scan the QR code to head to Hungry Minds. Grab your copy, start the quest, and own the blueprints of our world. What black holes are lurking next door? If you're looking for a safe neighborhood, the Milky Way isn't it. For decades, we thought the nearest monster was V616 Monocerotis, 3,000 light-years away. But the Gaia mission just exposed one even closer. Located only 1,560 light-years away in the Ophiuchus constellation is Gaia BH1. It's a dormant stellar black hole hiding in plain sight. It was only revealed by the desperate wobble of the star it's dragging through the dark. This is the first species in our bestiary, the nomads. These are the stellar corpses left behind when massive stars implode. We used to think they were easy to track because they usually stay paired with a companion. But Gaia BH1 is a sleeping giant. It isn't actively eating, so it emits no light, no heat, and no warnings. It's a city-sized sphere holding the weight of 10 suns, sitting literally in our cosmic backyard. And it's not alone. Just 1,900 light-years away sits its big sister, Gaia BH3. This nomad is a freak of nature, weighing 33 times the mass of our sun. It's the most massive stellar black hole ever found in our galaxy, drifting silently through the Milky Way's halo. Without precision satellites watching the stars move, we would be totally blind to its existence. The unsettling part is that we only find these because they have a hostage star that gives them away. Currently, astronomers estimate at least 10 million black holes are hiding in our galaxy, and a lot of them actively hunt. Thanks to the natal kick, a lopsided explosion during a star's death, some of these newborns are yeeted out of their home systems at hundreds of kilometers per second. These are the rogue nomads, naked hunters roaming the interstellar void. And now we know this species isn't just limited to small stellar corpses. Case in point, RBH1, that's at least twice more massive than the supermassive black hole in the center of the Milky Way. Thankfully, it's dragging its star trail 8 billion light-years away. But frankly, we have no way of knowing if one of the rogue nomads is headed for our solar system until it starts rattling the Oort cloud. So what if it appeared near Earth? You would not, as some people think, see a black disk on the horizon. A stellar mass rogue nomad would be only 60 kilometers in size, which is about the size of New York City. But because gravity isn't even, the side of the Earth closer to the hole would experience a more intense pull than the opposite side. This would lead to spaghettification. One side of the planet would be yanked with millions of times more force than the other. Tidal forces would turn our crust into ribbons of plasma, spinning into the singularity until the Earth is split into literally nothing. But as dangerous as rogue nomads are, they should be relatively rare. At least, that's the accepted theory. Current models suggest it is orders of magnitude more likely that an asteroid will end our civilization before a black hole ever pays a visit to the solar system. But if the nomads are the invisible, if occasional minds of the galaxies, the next species in our bestiary are the anchors, and they don't hide. Located 26,000 light-years away at the heart of the Milky Way lies Sagittarius A star. But don't let the name fool you. It isn't just a dead star. It's a 4 million sun monster crushed into a region smaller than the orbit of Mercury. For billions of years, this insatiable engine has been the heartbeat of our galaxy, dictating the orbit of stars in the galactic center. Sagittarius A star is the closest architect, one of the apex predators of the cosmic food chain. While nomads weigh as much as a few dozen suns, architects are measured in the millions and billions, and their gravitational influence spans light years. But in 2014, something happened that shocked the scientific world. A gas cloud called G2 defied death. It brushed the event horizon of Sagittarius A star and escaped at 10 million kilometers per hour. It later turned out G2 wasn't a cloud, but a star wearing a dense atmospheric shroud, and that's why it survived a near miss with our ultimate predator. Still, it is a polite eater compared to the titans of the deep. In the galaxy M87, there's a black hole 6 billion times heavier than our Sun. In 2019, it became the first black hole ever imaged directly, a terrifying ring of fire surrounding a shadow of pure nothingness. To put that scale into perspective, if a stellar black hole is city-sized, this architect is larger than our entire solar system. One wrong turn in this neighborhood and your existence is deleted. But the absolute king of this bestiary is Tun 618. Located more than 10 billion light-years away, Tun 618 is the ultimate ultramassive black hole. It has an estimated mass of 66 billion suns and a diameter of 390 billion kilometers, wide enough to fit 11 of our solar systems in a row. This gluttonous monster powers a quasar 140 trillion times brighter than our sun. It's a cosmic lighthouse visible from the edge of the observable universe. but as of 2026, Ton 618 may have been dethroned. Deep in the heart of the Phoenix cluster lies a new nightmare, Phoenix A*. It's a monster that defies even the ultra-massive categorization. Current estimates place its mass at a mind-breaking 100 billion suns. If Ton 618 is a lighthouse, Phoenix A* is a gravitational tomb. It grew to this impossible size by swallowing the central black holes of at least three massive galaxies during a chaotic triple merger. The scale of this architect is incomprehensible. Its event horizon has a diameter of 590 billion kilometers. That's 100 times the distance from the Sun to Neptune. Get this, if you were traveling at the speed of light, it would take you more than 2 months just to complete a single orbit around its circumference. But the danger of an architect isn't just its size, it's the lethal environment it creates. The black hole in Messier 87 devours matter so violently that it produces an X-ray jet 5,000 light-years long. If a civilization were to cross that beam of plasma, it would be vaporized instantly. Even Cygnus A, a smaller black hole, burps out radio tails that are 2.5 times longer than our entire galaxy. But what's truly unsettling is that you might not even realize you were being devoured. Unlike the tiny nomads that rip you apart in seconds, an ultramassive black hole has much weaker tidal forces at the event horizon. Time would slow down so significantly that you could theoretically cross the event horizon and live out the rest of your life inside, never realizing the Earth was being digested. The architects represent the absolute limit of gravity's power. They dictate the rhythm of the universe, anchoring entire galaxies in place. So, what could possibly be scarier or weirder than those? Here is where our bestiary takes a truly dark turn. We hit the greatest missing person case in the history of astronomy. Logic dictates that if you have city-sized nomads and solar system-sized architects, there must be something in between, intermediate mass black holes. This is the elusive angler's species. They should weigh anywhere from a few hundred to 100,000 suns, but for decades, they've been the most frustrating no-show in the universe. Finding one is like trying to figure out a specific shadow in a pitch-black room. You see, without these anglers, our understanding of reality falls apart. We don't know how a nomad grows into an architect. It's kind of like looking at a world full of infants and 90-year-olds, but never seeing a single teenager. If these intermediary black holes don't exist, then the giants at the centers of galaxies shouldn't exist either. But it looks like the hunt is finally paying off. In 2024 and 2025, scientists began finding the smoking guns hidden in the most crowded places. By mapping the frantic whipping motions of stars at the very center of Omega Centauri star cluster, astronomers have inferred that a hidden elusive angler weighing thousands of suns is tugging on them. In 2024, Hubble and Gaia confirmed 7 fast-moving stars in Omega Centauri that prove an intermediate black hole is lurking right there. It weighs at least 20,000 times the mass of our sun, hiding in our own galactic backyard. Another clue is sitting 290 million light-years away in a dwarf galaxy called HLX-1. This is the near-perfect example of our missing species. It's also an object about 20,000 times the mass of our sun, and it occasionally lights up with X-ray flashes when it consumes a passing star. These rare events are like a lightning strike in the dark, giving us a fleeting glimpse of a species that prefers to stay hidden. We've even caught ripples in space-time, gravitational waves from mergers like GW195521, which produced a black hole of 142 solar masses. It was our first definitive proof that nomads can merge to build an intermediate mass black hole. And that's 3 of them. The creepy thing is, this species shouldn't be this rare. If the universe is a factory for black holes, the intermediate ones should be everywhere. The fact that they're so hard to find suggests some gap in physics. Are they simply too quiet, drifting in the intergalactic void where there's nothing to eat? Or does nature skip this stage entirely, jumping straight from small to massive through a process we haven't discovered yet? If we were to stumble upon this elusive angler, it would be truly horrifying. Its event horizon is about 60,000 kilometers wide. That is barely 5 times the diameter of the Earth. But remember, it wields up to 20,000 solar masses. If it hits the sun, it wouldn't be a collision. It would be a tidal disruption event. As it approaches, the tides of gravity become so steep they overcome the sun's internal pressure. Our star would literally lose its round shape, stretching out into a long, glowing strand of gas, a spaghettification on a stellar scale. Half of the sun's guts would be flung out into the void at thousands of miles per second, while the other half would wrap around the angler, forming a blindingly hot accretion disk. For a few brief weeks, the solar system would be lit by a flare brighter than a billion stars. The death scream of our sun before the angler falls silent again. In fact, its mass tells us that it should have devoured multiple stars, but there's new evidence that the most ancient black holes had nothing to do with stars at all. You see, as the James Webb Space Telescope looks deeper into the void and into the past, it keeps finding impossible black holes. Webb found monsters like UHZ-1 already weighing 40 million suns just 470 million years after the Big Bang. This Leviathan species creates a massive mathematical nightmare. If black holes are just dead massive stars, this seed would have had to eat at a rate that violates the laws of physics to get that big that fast. To grow a million solar mass giant in that time frame, the parent star would have had to be a single glowing ball of gas weighing over 100,000 suns. Such a star is a physical impossibility. Its own radiation would blow it apart before it could even finish forming. So, if the stars weren't that big, how did these holes get there? The possible answer arrived in July 2025 with a discovery in the Infinity Galaxy. Astronomers identified a newborn supermassive black hole weighing 1 million suns that wasn't in the center of a galaxy. It should have been born in the no man's land between 2 merging nuclei. But how? The only viable theory is something called the direct collapse. This states that the violence of a cosmic collision compressed a massive gas cloud so forcefully that it bypassed the star phase entirely. Instead of fragmenting into tiny suns, the entire cloud, 1 million suns worth of matter, collapsed into a single heavy seed all at once. What we are witnessing is the birth of a supermassive giant in real time, proving nature can skip the billion-year growth process. And this has even deeper implications. If this happened 8 billion years ago, it happened even earlier, at the dawn of time. This brings us to the most ancient species, primordial black holes. These are the seeds that probably didn't even need a gas cloud. They were born in the first fraction of a second after the Big Bang, formed from the raw, chaotic density of the birth of time itself. While direct collapse creates giant leviathans, primordial black holes could be any size, from the mass of a mountain to the mass of a planet, formed before the first atom ever existed. If these primordial seeds are real, they could be the elusive dark matter scaffolding of the universe. They're the reason galaxies were able to form, acting as gravitational anchors for the very first star clusters. In fact, trillions of these microscopic fossils could be drifting through our galaxy right now, invisible and silent. They imply that we aren't living in a universe of light, but but a universe of shadow, where stars and planets are just temporary decorations on a cosmic skeleton made of ancient nothingness. But here's the thing. If trillions of these microscopic fossils are really drifting through space, we should see them microlensing, distorting the light of distant stars as they pass in front of them. We should hear the pop of the smallest ones evaporating into gamma rays. Yet, despite our best efforts, we don't see anything like it. We simply don't know how many primordial black holes could still be wandering around our galaxy. We don't know if the direct collapse Leviathan we saw is a rare freak occurrence or the standard story. Most physicists argue that both of these species are too rare to solve the dark matter conundrum. This leaves us in a state of cosmic vertigo. Even with the James Webb's amazing capabilities, our black hole bestiary is still mostly blank in almost all categories. In other words, we have the list, but we don't have the census. Still, there's a theoretical black hole species that blurs the line between gravity and the subatomic world: the freaky quantum black holes. Such black holes should have the size of an atom and the mass of a mountain. In theory, they can be formed when a microscopic region of space is suddenly hit with the energy of a supernova. In that instant, a quantum black hole is pinched into existence. But unlike their massive cousins, these tiny species are inherently unstable. According to Stephen Hawking, these tiny black holes should evaporate swiftly and violently through Hawking radiation. But there's a curious theory that the evaporation hits a hard limit at the Planck scale. The black hole might reach a point where it can no longer shrink, leaving behind a stable microscopic remnant. If this is true, then every quantum freak ever born since the beginning of time is still out there. Trillions of these subatomic monsters, each with the mass of an asteroid, could be drifting through the vacuum of space like invisible dust. But don't worry, if any of them hits Earth, it'll go straight through the planet. For us, it will look like a meteor impact with no meteor pieces left at all. Freaky. So, what's your favorite species in this bestiary? Let me know in the comments. And if you want to ensure the blueprints of our world survive whatever the void throws at us, don't forget to grab your copy of the Ultimate Guide to Rebuilding a Civilization at the link below.